Today we are diving into an important programming concept, and that is recursion. This is when a function calls itself, and it's a common technique used in many real-world problems like calculating factorials, solving puzzles, and navigating tree structures. So let's break it down for beginners in the simplest way possible. So first question is, what is recursion? Recursion is when a function calls itself to solve smaller instances of the same problem. It needs a base case to stop the loop and prevent infinite recursion. For example, we can create a function called func, and inside that we can call that function func. Okay, so calling the function inside that function means it is a recursion, but we always need a base case to avoid endless calls or infinite calls. So here let's have a parameter called n, and in the function body let's have a condition if n equal 0. If that is the case, we want to just return. Otherwise, we want to call our function, but this time with n minus 1. So we are reducing the value of the provided parameter by 1. Okay, so this is how we create a recursive function. Now if I run the code, it will do nothing, but to make this real world function, we can rename this. So we can call this function count down. Then if n equal 0, we want to print it is done, and we want to return also. Otherwise, if n is not equal 0, we want to print n. After printing the current n, we want to call the countdown function again, but this time reducing the parameter value by 1. Now again, if I run the code, you will see nothing got printed because this function will call itself, but for the initial call, we have to call that from the outside. So I have to call this function, and for parameter, I'm gonna pass 5. Now if I run the code, you'll see it prints 5, 4, 3, 2, 1, and then when n becomes 0, it prints done. So what is happening is, in the first function call, 5 is there inside n. So this logic is not true because n equal 5 not equal 0. So it goes to the outer block, does not goes to the if block and prints 5. Then again it calls the countdown function, and previously it was 5. Now this time it calls the countdown function by reducing by 1, means 4. So again goes to the function. Now n is 4 not equal 0, so it does not go inside the if block and prints 4, and then it reduces by 1 and call the countdown function again with the value 3. Okay, so for now in the function n is 3, which is not equal 0, so it does not renders this part and goes to the next line and prints a 3, and in the next line it reduces by 1 and becomes 2, and now it calls the countdown function with the value 2. Then again it goes to the function. This time it calls the function with 1, and as you can see it printed 1. But after the last time when n become 0, after reducing by 1, now n is equal 0, so it prints done and a return. That means it stops calling itself because it does not go there. Before that it just returns. Okay, so let me comment this example. Now there is a famous thing in mathematics, and that is factorial, and let's see how we can solve some problems like factorials using recursion. So we can create a function called a factorial, and there we can pass n, and there we can have n as parameter, and here we're gonna say if n equal 1, if that is the case, we want to return just 1. Otherwise we want to return n into, then we are gonna call the factorial function and n minus 1. Okay, now it won't do anything unless we call from the outside for the first time. So here I'm gonna write the print statement and write factorial and pass 5 as argument. Now if I run the code, you will see it prints 120. So what is happening is, when we first time call factorial function, n is 5. Okay, so that is not equal 1, so it does not executes this line but goes to this line. So n is 5 into, and if we do factorial n minus 1, so we are calling that function again, so 5 minus 1 means 4. Okay, so ultimately now we have 5 into 4. Again it comes here, and now it calls the factorial using the value 3. Okay, so again it goes to the function. Now n is 3, which is not equal 1, it does not execute this line, and it goes to this line, and with these values it add star 2, because 3 minus 1 is 2, so it calls the factorial function again with 2 as well. So now n is 2, which is not equal 1, so it does not execute this line, so it goes to this line, and now n becomes 1, so now it goes to the function again. So 1 equal 1, this is true, so it returns 1, so it does not goes to this line anymore, so the ultimate result becomes 120. So if I run the code, you will see the output 120. So if I show you a behind the scene process with some comments, so it is working like this. So it was factorial, then we are calling this with the argument 5, then in the next line we have equal 5 into, then factorial 4. Okay, and in the next time when it calls the function, it becomes 5 into 4 into factorial, and we call this function with the value 3. Okay, and in the next step it becomes 5 into 4 into 3, and again we call the factorial function with the value 2. Again in the next line we get 5 into 4 into 3 into 2, and we call the factorial again with the argument 1, and lastly what we get is 5 into 4 into 3 into 2 into 1, and that's how it becomes 120. Okay, so I hope you understood how it is working behind the scenes. It keeps calling itself with n minus 1 until it hits the base case n equal 1. Then each call returns and multiplies back up. Now let's have another example, and this is another interesting thing in mathematics, and that is sum of natural numbers. So we can create a function called sum numbers, and here we expect a parameter called n, and here the base case would be if n equal 1, we want to return 1. Here I missed the colon. Okay, and we want to execute, so return n plus, we want to call some numbers function with n minus 1. So if we want that this should be called for the first time, we have to call that from the outside. So I'm gonna call that some numbers with the argument 4, and let's print that as well. So I'm gonna write the print statement and pass some numbers function call inside that print statement. If I run the code, you'll see it prints 10. So in the first call n is 4, so here we say 4, then plus, and we call some numbers function again with 4 minus 1 means 3. We pass 3 as argument, which is not equal 1, so it does not execute this line, and we get 3 here, and again it calls the function, this time and becomes 2. So 2 is not equal 1, it does not execute this line, and in this line we get 2, and this function gets called again, now this time with the value 1. Now 1 is equal 1, so it returns just 1 and does not go to this line again. This is how it becomes 10. Well, 10. So now if I visualize this, like before. Here, first we are calling some numbers with argument 4. Okay, in the next line we get 4, then plus, and the sum numbers function calls itself, and this time with the argument 3. In the next line it becomes 4 plus 3, and we call the function again with the value 2. In the next line we get 4 plus 3 plus 2 plus, we call that function again, but this time with the argument 1. And in the next step we get 4 plus 3 plus 2 plus 1, and this is how we get the output 10. So every time a recursive function calls itself, Python stores the current function on a call stack. Once it hits the base case, in this case this one, it starts returning values back one by one. Think of it like stacking plates. Once done stacking, you return them from the top one by one. So now let's discuss about some risks of recursion. So risks of recursion. So the first risk is, if you write a function def ini, for example, and if you call that function inside that function, but if you do not include a base case like this one, it will become an infinite function. The function keeps calling itself infinitely. So if I call this function from outside, it will become an infinite recursive function. As you can see, it says maximum recursion depth exceeded. So when working with recursion, make sure to always provide a base case. Means when a function should stop calling himself, because Python has a recursion limit and the default is 1000 calls. Now when to use recursion. So it is good for breaking problems into smaller identical problems, for example tree or graph traversal, sorting algorithms like quicksort, etc. So the summary is, in this video we learned what recursion is and how it works, how to write a base case to stop recursion, and we saw some real world examples like countdown, factorial, and a number sum. So that's all for now. See you in the next one.